Minasan, konnichiwa, Zamurai Engineer desu. So in this video, let us continue our discussion of actually module 1. This is now module 1. More preparatory explanation of introduction, wherein in this particular one, we will focus on steel as a material, as engineering construction material. Okay. So again, not only the material, we will talk about its origin and many more about steel. As soon as we are able to talk about what is steel, its characteristic, its origin, its history, we will go to more detailed topics. Okay. So our course is Principles of Steel Design, CE E6, and this is a professional course common to all civil engineering students. It provides fundamental concepts, principles, and theories under structural analysis and design of steel elements in an structure. So we have the following topics throughout the whole semester, and we are right now on the introduction part, wherein we have what? The following subtopics. So module 01 is use and application under the introductory part. Okay. So let's talk about steel, all about steel. Historically, woods is a steel developed in India. So the comparatively the earliest use of steel. So 300 BC, okay? 300 years before Christ. The word woods is a mistranscription of uko, the word for steel in Telugu. Telugu is a language, a regional language, a dialect within India Peninsula. Okay? The pillar is fabricated in 310 AD, okay, in India. It has all along been outside as an astronomical observatory aid. So you can see in this picture, this is the what? The steel structure. Just a column or just a post, but its usage is for astronomical observatory aid. Okay? Okay? It will what? It is a fixed structure on Earth which would give us the reflection from what? Moon and sun. And studying the reflection, the angles, the height. So they will relate those variables and therefore compute or estimate astronomical occurrence or phenomena. Okay. So as you can see, it never rusted. 310 AD. Okay. So 300 years BC, woods is developed, but this particular pillar, okay, is 310 AD. So, okay, so AD meaning in the year of our Lord. Okay, so still, this is in India. It is about what? 7.21 meters in height, including the footings that is actually buried underground. 41 centimeter diameter and weigh about 6 tons. So this particular structure, as you can see, it is good that we have a picture together with somewhat tourists because the height of the tourist is the height of common human being. Okay. So, for example, the height of average height of those person, about 5'5". Okay, so you can what? You can compare it to the height of the pillar or the structure. Okay, it is made by forged welding. Imagine the technology used. There are no equipment, there are no machinery, but they can forge. Okay, so it never rusted. So those are important things to know. Okay, historical value, never rusted, forged welding. Okay. After which, Damascus steel is a hot forged steel used in Middle Eastern sword making from about 1100 to 1700 AD. Okay, so 1100, we are not yet discovered by Spaniards. Okay, our country is not yet discovered. So 1100, so 1700. So the sword making technology, as you can see on your picture on the right side of your monitor. So that is what we call what? Damascus steel. Okay, Damascene steel pocket knife. Okay. So just by the look of it, it looks strong. It looks what? Beautiful. Okay. Look at the lines. Okay. Okay. Arbitrary, random lines. Okay. So Damascus swords were legendary sharpness and strength. Okay. Legendary. Look at the cutting edge. So we have the cutting edge on your right side, and the back side is the non-cutting edge. Okay. The dull end, the sharp end. Okay. Sharp side and the dull side. Okay. And were apocryphally claimed to be able to cut through lesser quality European sword and even rock. Take note, it can cut through another metal of good quality and rocks. Okay? The foundation for Damascus steel is wood steel, which originated in India and later spread to Persia. Persia is actually a country now called Iran. Okay, that is Iran nowadays. So Damascus is a city inside Iran. Okay, it's still a city right now. No? Ancient use of steel, beginning 5th century. 5th century meaning 1400. Okay, 1400. That is the 5th century meaning 500. 400 rather. Okay, year 400. Okay, 400 BC. 5th century. Weaponry, ornamentals, and bridge construction in India. Small suspension bridges in Middle East and China. Okay, so as you can see, you have a small suspension bridge. That is what? Here at the picture below, that is a suspension bridge. So as you can see above, you have what? Arc bridge, arc type bridge. Okay. So early usage again. So ancient and early. So ancient is before Christ to about 1100 no? AD. Early use 1700, 1777 to 1779. First cast iron bridge in England. Okay, so casting of iron is now available. Take note of the word cast iron. It doesn't say cast steel. So there is a difference between iron and steel. So this is what? Cast iron. So iron is the main component that is used in order to cast some steel parts into its particular shape. Okay? In 1780, after that, up to the 1820, several bridges all over Europe, preliminary rolled shape manufactured. Okay? So after that early use, there's a big boom of usage for bridges. Okay? So 1820, rails manufactured. Okay? 1840, advent of wrought iron. Another technical word, wrought iron. Okay? This is read as wrought iron. Okay? So there are now what? Steel, cast iron, and wrought iron. However, in Japan, historically, Japanese sword making from special steel forging is legendary. It is also legendary, much like as what? The Damascus steel. Okay? Because in those times, war is the common occurrence, and they have either to protect their own place, to protect their own country, or what? Control another area. So that is the purpose of this sword. Okay? As a weapon, it is still practiced with very laborious, intensive process up to now. So we're able to learn something, but most of it are actually learned through practice, through actual what? Through actual some sort of OGT. Okay? Okay, so some sort of OGT, and you must be accepted by the master. Okay, it cannot be learned in school. It is always learned by subjecting yourself as a what? As a worker under the wings of a known master. Okay, master meaning blacksmith. The blacksmith, which is now having the skill and the know-how to produce that good quality of sword. Okay, I actually have a personal sword which was gifted to me by a mechanical engineer. Okay, so I will show it probably later on. I will show the what Japanese sword, which is called what? Katana. Okay, so it is still practiced with very laborious, intensive practice. Okay, up to this day. Actually, they have what? They have currently some sort of a license. You cannot be a blacksmith without a license in Japan because these are weapons. Okay, these swords are dangerous weapons. Okay, you need a permit, you need the license in order to do this. Okay, and you also need the license to carry it, much like a gun, it's a weapon. Okay, you need a license to carry it. That's why there are very seldom you can see somebody walking in Japan that carries sword because the licensing of this is actually controlled by the government. Okay, China also has had a very ancient steel industry for sword making, guns, and other weaponry because these are the what oldest. Japan, China, they are the oldest what civilizations. Okay, and that's why they are preparing to protect themselves from external enemy, and also they want to what to control other areas, other country, other nations. Okay, so that's why they what develop better quality so that during the the war, they have the advantage. Okay? Modern day history. We have 1930s Golden Gate Bridge, okay, a very famous bridge in what? In California. Okay, as you can see in the picture above here, the Golden Gate Bridge, and also we have the Empire State Building. So this is the Empire State Building in what? In New York. So California, New York, they are extreme places in the United States. Okay, they are both what? Big cities, city center. That's why they are able to build very this structure that became popular. Okay, so 1960s, Shear's Tower. Okay, so there are so many buildings around the world. Okay, okay, so there are so many buildings around the world. Okay, as you can see, this one is the Empire State Building. So this one in New York, Empire State Building. So building is different from tower because buildings are designed to what? To be occupied by human being, by people. Okay? Towers are usually designed and constructed in order to support some load. Okay? Or for other purposes like the pillar, which is for what? It doesn't support any load, but it is constructed to stand up in order to be an observatory, astronomical observatory aid. Extensive use of steel for medium to high-rise building is becoming a boom, even in our country. Okay? Even in our country, the current highest building in our country is located in our city, in BGC. That is in the global city. Okay, so that is the highest. So equally extensive use of steel in industrial structures, airport, and the like. So almost on all areas, there are what? Extensive boom in the use of and application of steel. Okay, because they already noticed that they can use it in that way, they can use it in that way, or therefore they are what? Learning from the actual, okay? Learning from the those first structure. Okay? So we have for the towers. Okay, these are the towers that are not designed to be occupied by human being, but human beings can go there in order to what? Visit, take a look as a tourist. Okay, so it is not for human being or people occupancy. That is not for occupancy. That is for other purposes. For example, these towers are mainly for what? For tower for telecommunication. Okay, telecommunication tower. Okay, so as you can see, the current highest tower in the world is Tokyo Sky Tree, located in Tokyo, Japan. Okay, the second is Canton Tower in Guangzhou, China. The third highest is in Toronto, Canada, the CN Tower. Okay? So those are the different towers that are popular currently. So this is the actual photo of Tokyo Sky Tree. This is actual photo of Tokyo Sky Tree. Japan had a plan to build a 1 kilometer high building, but it does not. It did not pursue because of pandemic, and I think they stopped it already. They stopped the plan already. Okay, so therefore we cannot expect anything that is about 1 kilometer high building. Okay. So the Burj Khalifa is about 800, I think about 800 meters. So 200 meters short of 1 kilometer. Okay. So what is 200 meters? What is very long? 200 meters is very long. So 200 meters is about 50 floors. And take note, the highest building in our country is less than 50 floors. Okay, so you have to put 50 floors on top of Burj Khalifa. Okay, okay, so in Dubai. Okay, so we are talking of Sky 3 here, Tokyo Sky 3, and you will notice the shape. This is 0 meter, so the ground level at 170 meters, the shape is different. Initially, the shape is what we call what? Triangular shape. The cross-section of the tower is triangle at the ground level. 170 meters going up. Now the shape is what? Still some sort of triangle, but it with legs curving, much like a what? A circle, no? Circular curve on its legs, okay? On its sides, okay? On the sides. Okay? 445. Okay, another cross section different from 170, and at 320 meters the cross section now is circle, and 350 there is what? There is some sort of pad. Okay, in this case we have a circle here in this area, circular cross section. Then we have a pad supporting the what? The tower above it. So at 450 meters, we have another what? Connection. Okay, so and then so on up to the highest portion wherein they can what? They can put on the TV or Wi-Fi or other telecommunication device, okay, for transmission or transmitting signal. Okay. So another use of steel, we have what? The shape, right? This is a very good example of why steel is being used here. Take note of the steel structure. In one unit, we have a beam, and the beam is actually going down to become what? To become the legs or the column itself. No? So legs going up and become a beam. So legs going up and become, okay? Okay? So that is one very interesting use of steel. Okay? So this one is an international airport in Mumbai, India. So another interesting steel structure, we have what? A bridge, okay, at Glen Canyon, Colorado. So we have a bridge structure and arcs, bridge, that support the main bridge, which might be what? Of concrete structure. Okay, the surface or the pavement may be concrete, but the supporting structure are mainly what? Steel. Look at the bridge below. It is what? Or the fence. Okay, the fence or the dam. Okay, so this is the dam. Okay, the dam structure is, you can see, it is concrete. Okay, reinforced concrete. So another example of steel structure, which is the new river gorge bridge. Okay, in Western Hemisphere, it measures 876 feet from the bridge to the bottom of the gorge. So that's how high. Okay, that's how high it is. Okay, it is higher than the what? The clouds. It's higher than the clouds, as you can see in this actual picture. Okay. And this one is in Vietnam, what they call Bat Long Bridge, which means White Dragon Bridge. Okay, it is suspended at 150 meters. Okay, 150 meters and can carry 450 people. So, meaning to say, this is not for cars, not for vehicles, but for human being. That's why it is called pedestrian bridge. Okay, it is the world's longest glass bottom bridge. Oh. So the bottom of the bridge is not made up, the pavement is not made up of concrete or steel, but made of glass. So you can look down on the floor, and the floor is transparent because it is glass. And how high? It is suspended 150 meters high. Okay, so 800. So the previous one is actually what? This one is higher because 876. This one is higher. This is about 200. It's about 200. 250. It's about 250 meters. This is 150 meters. So that one is far more higher than this one. But take a look. This is the longest glass bottom bridge, right? Okay, so these are the things that generally we know about steel from its history, origin, and current application. So let us challenge ourselves. Take your notes and answer the following. You can rewatch this video and take this problem solving. Okay, and put your answer on the comment box below. So question number 24, as per specification, what is the minimum diameter of galvanized wire used for both gabions and mattress with a variation of plus minus 10 mm? As you can see, the background picture is the gabions and mattress application, wherein we have what? Galvanized wire being used to support, okay? To support this structure, stone, okay? Stone structure, okay? So letter A, 2 mm, letter B, 2.1 mm, letter C, 2.2 mm, and letter D, 2.3 mm. We are being asked, what is the minimum diameter of this steel? This is steel. This is steel structure, but not the way that we are going to design. Okay, we cannot go as far as this type of design. in this course. Okay, just to let you know, we made it as some sort of challenge question. Okay, so that's from our steel structure, and we can generalize the application of steel, the main structural types that we can use steel. We can classify into buildings and bridges. Okay, at your left side, we have what? The listing of application in buildings, and on the right side, we have the listing of application under bridges. So, buildings and bridges. So, for buildings, truss structure, either bar or truss members. Frame structure, we have beams and columns. Grid structure, we have lattice structure or dome. Okay, arch. Okay, we have all the example of this. We have pictures of this. So we are now familiar of this all. This is the exception. We will have an example of this much later. Okay. So for the bridge, we have beam bridge, truss bridge with truss members, of course, arch bridge, cable stayed bridge. Okay. So we have an example of this, and also an example of suspension bridge. So let us ask, where and when we can use steel structure? Because of this, we can generalize it to be application advantageous to steel structure. If there is a long span structure, multi-story and high-rise buildings of heavy-duty plants, and meaning power plants, no? Tower and mast structure. We also have an example. Portal frames, bridges, infrastructure, okay? Deployable structure, generalized structure in mechanical, for example. Okay, so steel design, therefore, is focused on designing the steel itself. Structure or structural components primarily made of steel members attached to each other appropriately. Steel is excellent in both tension and compression. They have almost similar characteristic in compression and tension, just opposite in direction. Since steel is primarily made in thin plate-like elements, they are susceptible to buckling. We have also an example of those, both local and overall buckling. Connection in steel are considerably different from those in concrete. In steel, the members are concrete, or rather discrete, or rolled, meaning fabricated separately and are attached to each other using appropriate connections. Okay. So we have the characteristic of the steel. Modern steel was first produced 1738, the same quality as of today. Okay, known as crucible steel, and that's very pure but difficult and expensive to produce. British inventor Henry Bessemer produced the first economical steel 1856, more than 100 years after the first commercialized steel. Okay. Today, steel is produced in over 50 countries all across the world. To every ton of Portland cement produced, 3 tons of wood and 10 tons of steel are produced. Okay, take note of the valuable characteristic of being a steel as construction material. 1 ton of Portland cement, 3 tons of wood, 10 tons of steel. Okay. In 2003, China was the first country to produce more than 200 million tons of crude steel in a year, meaning